290 million years after the Big Bang. The universe is barely 2% of its current age. According to every model in astrophysics, nothing should exist out there except tiny, shapeless clumps of hydrogen and helium, the raw, unprocessed ingredients of a cosmos still waking up. The James Webb Space Telescope pointed its 6.5-meter gold mirror at a patch of sky and found a galaxy. Not a dim smudge. A galaxy spanning over 1,600 light-years, blazing with the light of hundreds of millions of stars, already enriched with oxygen, an element that can only be forged inside stars that have already lived and died. Multiple generations of massive stars had formed, exploded, and seeded the interstellar medium with heavy elements before the universe was 300 million years old. The galaxy is called JWST-GS-Z14-0. It is the most distant galaxy ever observed by humanity, and it should not exist. But it's not alone.
The farthest galaxy humans have ever seen, Jade's GSZ14-0.
JWST has found dead galaxies that stopped forming stars when the universe was 700 million years old. 5 galaxies merging in a violent collision 800 million years after the Big Bang. Barred spiral galaxies with structural perfection that wasn't supposed to appear for billions of years. And complex organic molecules, the chemical precursors to DNA, surviving 100 million-year journeys through superheated galactic winds. The Standard Model of Cosmology says none of this should be happening. JWST says it already did. The most distant galaxy ever seen. JADES-GS-Z14-0 was identified through the JWST Advanced Deep Extragalactic Survey. Announced on May 30, 2024, the galaxy was confirmed at a spectroscopic redshift of 14.32, meaning we see it as it existed just 290 million years after the Big Bang. ALMA observations later refined the measurement to 14.1793. The physical properties defy every theoretical expectation. Despite its extreme youth, the galaxy spans over 1,600 light-years. Its light comes from young stars, not a supermassive black hole, ruling out the possibility that it's just a bright accretion disk masquerading as a galaxy. Its stellar mass is estimated between several hundred million and half a billion solar masses. And JWST's MIRI instrument detected strong oxygen emission, proof that multiple generations of stars had already formed, lived, and died in supernovae before the universe was 300 million years old. Oxygen is a heavy element forged exclusively inside stellar cores and dispersed only through supernovae. Its presence this early means the cosmic clock for mass assembly ran orders of magnitude faster than any model predicted. As University of Arizona astronomer George Reiki put it, nobody dreamed there would be galaxies this bright at this high a redshift. Galaxies that grew up too fast. JADES-GS-Z14-0 isn't the only anomaly. The Standard Cosmological Model, Lambda-CDM, predicts that early galaxies should be small, chaotic, and irregular. Ordered structures like spiral arms and central bars require billions of years of gradual merging and angular momentum conservation. JWST has found them appearing impossibly early. Sears 2112 is a barred spiral galaxy at redshift 3.03, when the universe was only 2.1 billion years old. It has a stellar mass of 3.9 billion solar masses, a concentrated central bar, and distinct spiral arms. Before JWST, barred spirals were not expected to exist until the universe was at least half its current age. Rebels 25 at redshift 7.31 is a dynamically cold, rotation-dominated disk galaxy observed just 700 million years after the Big Bang. Its structural perfection is irreconcilable with chaotic merger models. And ZF-UDS-7329 at redshift 3.2 is a relic elliptical galaxy with a stellar mass exceeding 100 billion solar masses, whose stars formed at redshift 11 in the first few hundred million years of cosmic history. The universe wasn't supposed to build things this big, this organized, this fast. The oldest dead galaxy. If finding massive galaxies too early is a crisis of assembly, finding dead galaxies too early is a crisis of evolution. JADES-GS-Z7-01-QU sits at redshift 7.29, roughly 700 million years after the Big Bang. It is the oldest and most distant dead galaxy ever discovered. Despite being only 650 light-years across, it contains between 400 and 600 million solar masses of stars. Stellar modeling shows it experienced a violent burst of star formation lasting 30 to 90 million years. Then, suddenly, it stopped completely, 10 to 20 million years before the epoch when JWST observed it. This is the paradox. The first billion years of the universe were saturated with cold gas. The raw fuel for star formation was everywhere. For a galaxy to build hundreds of millions of solar masses, then permanently shut down while surrounded by abundant fuel, requires catastrophic mechanisms that push the limits of physics. Either a supermassive black hole blasted every molecule of gas out of the gravitational well through radiation pressure and relativistic jets, or the initial starburst was so violently efficient it consumed the entire internal gas reservoir and shock-heated any incoming supply, or a concentrated wave of supernova feedback unbound whatever remained. As Tobias Lusser of the Kavli Institute summarized, everything seems to happen faster and more dramatically in the early universe. 5 galaxies colliding at the dawn of time. Published in Nature Astronomy on February 9, 2026, a team led by Dr. Wida Hu at Texas A&M University revealed a system they nicknamed JWST's Quintet. At redshift 6.71, 5 distinct galaxies containing over 17 star-forming clumps are locked in a violent, compact merger just 800 million years after the Big Bang. The system is extraordinary. 5 galaxies packed into a region just 24.6 by 24.6 physical kiloparsecs, a combined stellar mass of 10 billion solar masses, a star formation rate of 255 solar masses per year, 10 times above the standard main sequence for this epoch, and an enormous halo of oxygen-rich gas connecting the galaxies, proving that the merger's gravitational violence is tearing heavy elements out of the galaxies and distributing them deep into intergalactic space. This directly explains the dead galaxy problem. A 5-way merger triggers a massive starburst that rapidly assembles stellar mass, then strips and shock heats all remaining gas. The result? An ultra-massive remnant with no fuel left. Exactly the type of dead galaxy JWST keeps finding. But Lambda-CDM simulations assign this kind of multi-galaxy merger at redshift 6.7 an exceptionally low probability. The early universe was far more crowded and violent than the models predicted. The seeds of life in galactic wines. When galaxies die, their supermassive black holes don't go quietly. In a galaxy called Makani, JWST detected galactic winds spanning 326,200 light-years, driven by 2 massive starbursts 7 million and 400 million years ago. Those winds blast gas and dust deep into the circumgalactic medium at thousands of degrees. Astrophysicists assumed nothing delicate could survive those conditions. JWST proved them wrong. Professor Sylvain Velleau's team detected polycyclic aromatic hydrocarbons, complex carbon-based organic molecules, surviving up to 35 kiloparsecs from the galactic core. These molecules endured a 100 million-year journey through superheated plasma, shielded inside dense cocoons of cooler gas. Meanwhile, ALMA observations of the young protostar V883 Orionis detected 17 complex organic molecules in its planet-forming disk, including ethylene glycol and glycolinetriol, a direct chemical precursor to the nucleotide bases that form DNA and RNA. These molecules weren't built in the disk. They were inherited from the parent molecular cloud, surviving the violent birth of the star itself. This overturns the old cosmic reset hypothesis, the idea that star formation destroys all complex chemistry, forcing life's building blocks to start from scratch on every new planet. The data shows the opposite. Prebiotic chemistry is assembled in deep space, survives stellar ignition, and is seamlessly inherited by planetary systems. The seeds of life are manufactured in the void and distributed across the cosmos by galactic processes. The implications for the Drake equation are staggering. If planetary systems inherit intact DNA precursors directly from interstellar space, the fraction of planets that develop life may be exponentially higher than anyone estimated. Why only JWST can see this? None of this was visible before JWST. Light from galaxies at redshift 14 has been stretched by the expansion of the universe entirely out of the visible spectrum and deep into the infrared. Hubble's 2.4-meter mirror peaked between 0.1 and 2.5 microns. JWST's 6.5-meter gold mirror covers 0.6 to 28.5 microns with over 6 times the light-gathering area. It operates at 50 Kelvin, negative 223 degrees Celsius, at the L2 Lagrange point, 1.5 million kilometers from Earth, where a 5-layer sun shield blocks all thermal interference. Its NIR-spec instrument uses a 250,000 microshutter array to capture spectra from up to 100 galaxies simultaneously. MIRI sees through cosmic dust to detect oxygen emission and the spectral signatures of organic molecules. Together, they detect objects 10 to 100 times fainter than Hubble's absolute limit. What the models got wrong. Lambda-CDM predicted that early galaxies would be small, chemically pristine, and structurally chaotic. JWST has found them massive, metal-enriched, structurally mature, and in some cases already dead. The model's predictions for mass assembly rates, chemical enrichment speed, and star formation efficiency are fundamentally at odds with what the telescope is seeing. Theoreticians are proposing radical fixes: a top-heavy initial mass function, meaning early stars were disproportionately massive and luminous, making galaxies appear more massive than they are. Primordial black holes formed in the first fractions of a second after the Big Bang, acting as gravitational seeds that accelerated galaxy formation. Primordial magnetic fields that compressed gas and catalyzed structure formation faster than gravity alone. Even modifications to the expansion history of the universe itself. Whether this is a fatal crisis or a necessary refinement, JWST Cycle 5 will help decide. Starting July 2026, 8,009 hours of prime observation time across 254 programs will target the earliest galaxies, with NIR spec accounting for 54.7% of instrument time. The 1,000-hour LAPIS survey will search for galaxies beyond redshift 16, and the Nancy Grace Roman Space Telescope, launching by mid-2027, will survey fields 100 times wider than Hubble, feeding tens of thousands of high redshift targets to JWST for spectroscopic confirmation. JWST has found a galaxy 290 million years after the Big Bang with the mass of 500 million suns and oxygen forged inside stars that already died. It found a dead galaxy 700 million years after creation. 5 galaxies colliding at redshift 6.7. Organic molecules surviving 100 million year journeys through superheated plasma. Barred spirals existing billions of years before they should. The Standard Model of Cosmology says none of this is possible. The data says it already happened, and the telescope that proved it has 8,009 more hours of observation starting this July. Whatever it finds next could confirm the greatest revision in cosmological theory since the discovery that the expansion of the universe is accelerating.